My name is AJ and I'm on FTC Team 5040 Nuts and Bolts. Welcome to our introduction to programming tutorial. Some of the things we're going to be going over today is the software required to get your FTC team started. We're also going to be going over pulling a project from GitHub. This is going to be sort of setting up your workspace on your computer where you're going to be programming. We're also going to go over programming a motor and programming that motor to work with an external controller that will be plugged into your driver station, and programming a motor to work with an encoder, and programming a servo. Some of the things you're going to need for this tutorial is you're going to need a driver station, or you can use an FTC legal Android phone, which you can find in Game Manual 1. You're also going to need a control hub and some assorted wires, but most of those wires should come in packages with these other required hardware devices, so there shouldn't be any extra wires you need to purchase. You're also going to need a motor and a servo programmer. We will be using a Rev servo programmer in this demonstration, and we will be using a driver station instead of an Android phone for our tutorial. And also, in order for this tutorial to be the most useful for you, you're going to have to know Java ahead of time. If you don't know Java yet, you can learn for free at codeacademy.com or sololearn.com. These are both completely free, great online tools you can use to learn Java. You don't need to know robot Java yet, which is programming Java directly for the robot, like how to make a motor run. That's what we're going to be going over in this tutorial, but you do need to know some basic Java functions for this tutorial. Some of the required software you're going to need is Android Studio. Android Studio is where you're going to be writing all of your code for your robot this season. So make sure you download that at that link there. You're also going to need GitHub. The desktop version of GitHub is not required, so there isn't anything you need to download here, but you will have to go to github.com and make an account. And we also have the driver station APK. This needs to be downloaded on your driver station or on your Android phone. This is not something you need to download on your computer that you are going to be using to program. Now we're going to hop over to GitHub to show you how to pull a branch and set it up on your computer so you can begin to program.
Alright guys, these are the main components on our robot that we're going to be using today. First is our control hub. This is what all the hardware on the robot's going to plug into. All of your motors and servos are going to be plugged into this, and this is how you're going to control them. Here we have our battery. This is going to be the main power supply on your robot. It's going to plug directly into your control hub to power everything on your robot. Here we have your driver hub station. You can also use one of the legal Android phones found in Game Manual 1 for FTC. But this is what your controllers are going to plug into, and this is going to communicate with the control hub to wirelessly control your robot.
The first step in setting up your control hub is to plug in your battery. Different batteries will have different connectors, but in our case we have a battery with this Anderson power pole connector. You might also have a battery with this XT30 connector, or you might have one with a Tetrix battery connector. But whatever the case is, you need to get the appropriate adapter for your battery, and then plug it into the control hub here. And you can see this is keyed, so you can't plug it in the wrong way. But for the next step, if you try to plug in the battery to that, you can see that it ends up checkered. That happens sometimes with these power pole cables, so if that's the case, you'll need to grab an adapter cable like that. That flips the polarity. And now, it's not checkered, because you never want to leave those power pole cables checkered. And you can see this blue light turns on. Once that turns green, that means that the network is up and you're able to connect to it. But while we wait for that, let's grab our driver hub and get ready to connect. So now that our driver hub is set up, we're going to move back to our control hub and plug in our motor. So you're going to need this cable right here, and you're going to plug it into one of the motor ports on the control hub. And once that's plugged in, we can get our motor and plug in the two power poles together. And that's it. Now our motor is set up and we're ready to set up a config in our driver hub. Alright, so now that we've plugged in our motor, we need to add it to our config. A config is just a way of telling our robot what is plugged into what ports. So to do that, we're going to go into those 3 dots in the corner and hit configure robot. And then hit new. And it should automatically scan for hardware devices. We're going to select our control hub and go to motors. And our motor is plugged into port 0, so we're going to click on that and select what type of motor we have, which in our case is a Go Build of 5202 series. Now we need a name for our motor, and we're just going to call this Motor 1. And you're good to go. Now just hit done, done, done again, and save. And now we need a name for our configuration. We'll just call this tutorial. And then hit OK again. And your config is done, and we're ready to write our code.
First step in creating our program is going to be to make a new Java class in the team code folder. Now we want that class to extend op mode. And if you hit Alt Enter, it will import the class, and then hit Alt Enter again and you can implement methods. So this initialize method here is going to be what runs when you hit the init button on your driver station. And this loop method is going to be what it's going to repeat when you hit the start button. So now we need to create our motor. And let's go to the initialize method. And now we're going to use this hardware map, which is how you go from your config file telling you what what ports everything is plugged into, and then take that into your code. And now hardwaremap.dcmotor.get. And now this string in here is going to be whatever you named your motor in your config file. So in this case that was motor 1. And you might also see this as just doing hardwaremap.get, and then you can do dcmotor.class. And then the same thing, motor 1. These two are equivalent. The only difference is sometimes for some hardware objects you're not going to be able to do the first one. They're just not there, and you're going to have to do the second one. But for motors you can do the first one and they're going to be equivalent. And now to start running our motor, we just do motor.setPower, and now the double parameter that this takes is just going to be the speed that it runs at. So 1 will be full speed, 0 will be stopped, and -1 will be moving full speed but backwards. And let's just give it power 1 here. Then at the top of our program we need an @autonomous, and this is how you tell the program where you're going to find it in the driver station app. You can also do @teleop, and that will mean that you'll find it under the teleop programs, but we want this to be an autonomous program. And now we also need to give it a name, so let's just call it motor. And now you're ready to download your program. You can just plug in your control hub and hit the play button to download.
Thanks. Alright, so now that our program is written and downloaded, we're ready to start running it. To do that, go into the app and then select Autonomous and find your program. And then click Initialize and Start. And our program will start running.
In this section we're going to talk about controllers and go briefly into the code that we're going to use for controllers and how we can convert our motor code to change the speed of the motor with a controller input. And controllers are going to be very useful as you start getting into teleop code. The code for using a controller with your motor is going to be very simple. So all you need to do is change that 1 to gamepad 1. You could also use gamepad 2. Gamepad 1 is going to be the controller that you hit start A with, and gamepad 2 is going to be the one you hit start B with. And now you can see there are all these different button options here, and each of these are just going to output whether that button has been hit or if it's a joystick or one of the two triggers, how far down it's been pressed. And in our case, we do want to use one of the triggers, so we're just going to say gamepad1.left trigger. And that's all there is to it. You're ready to download your program.
So now that our code is written, we're ready to set up our controller. You can see all the Leo controllers on screen now. But today we're going to be using a Logitech gamepad. And all you need to do to set up your controller is take the cord and plug it into one of the USB ports on the driver hub. And if you're using an Android phone instead of a driver hub, you'll just need some sort of micro USB to USB adapter. So now that our code is written, we can start the program. And you can see, right now it's doing nothing. But as I press down onto the trigger, the motor will speed up.
In this section, we're going to be talking about encoders. Encoders are just a sensor that are going to measure rotation. Encoders are usually broken down into two categories: internal encoders, which are built into the motor, and external encoders, which are outside of the motor and can be put onto some sort of shaft. In our case, we're going to be focusing on internal encoders and how you can use these encoders to run a motor to a specific position, which can be very useful in both autonomous and in automating certain parts of your teleop program.
So now that we're ready to plug in our motor encoder, first thing we need to do is get this I2C cable and plug it into the port directly below your motor. And then get a level shifter and plug it into the I2C cable. Next, get one of these motor encoder wires here and plug it into the level shifter. And now plug that into your motor. And that's it. And we're ready to program an encoder.
So to have our motor run to a position, the first thing we want to do is change this op mode to linear op mode. And you can see this linear op mode is only going to have one method in it by default, this run op mode, where the op mode had the init and the loop method. So while op mode would loop once you hit play, run op mode is just going to run through everything in order, starting from the moment you hit initialize. So the linear op mode is usually what you're going to use for an autonomous program. You don't have to, but it's hard to make an autonomous with this loop. And teleop is often going to be made with the op mode, although again you don't have to do that. So let's copy this into the start of our run op mode method, and let's get rid of these two methods here. And now we want to add in wait for start, which is just going to wait until you hit the start button. So everything above that is going to be what runs right after you hit initialize, and everything below it isn't going to run until you hit start. So now we need to set the run mode on our motor. So to do that, just say motor.set mode, and now DC motor dot run mode. And you can see there are going to be all these different modes here. By default, it's just going to be running without an encoder. We want to change it to stop and reset encoder. And this is just going to reset the encoder value to 0. Now we're going to copy that and change the run mode to run to position. And now this is going to run to whatever target position we give the motor. So let's first set the power. So again, how fast it's going to run to that position. And now set a target position. And let's give it the position 1000. And now you're ready to download your program.
So now that we have our program installed, we're ready to start our program. And you can see that the motor will stop at the position we set.
So now that we've taken a look at running to a position, let's talk about some of the other options there are with the motor. So first, in the run mode, you can set it to run using encoder. The difference here is going to be that, unlike with the run without encoder, where the set power is just going to control how much power it sends to the motor, this is actually going to control the speed of the motor. And if there's another force acting on the motor, like let's say you're running a lift upwards and there's the force of gravity, or there's the force of friction working against your drivetrain, it's going to use something called a PID loop, which is not something we have time to get into today, but it's a controller that's going to be able to account for those external disturbances, and it's going to change the power to reach that speed as a percentage of the maximum speed instead of just as a power. You also have some zero power behaviors. So this is how your motor will behave when you set it to run at zero power. So now, again, this is similar to the run mode where you're going to say DC motor.zero power behavior, and now the two options you have are going to be brake or float. And brake is going to try to stop the motor in its place, while float is just going to let it keep going however fast it's going without trying to slow it down. Usually you'll want to set it to brake, but there can be use cases where float can be useful. And that's most of the main options you're going to be using with the motor.
In this section, we're going to be talking about running servos. Servos are usually broken down into two types: continuous rotation servos and regular servos. In the picture you can see here, this is a dual mode servo, which means it can act as either a continuous rotation or a regular servo. And really the difference here is that a continuous rotation will spin freely, you'll set the power and it'll just spin freely, whereas a regular servo will spin to positions within a certain range. Usually if you have a dual mode servo like this, you can set it to continuous or regular servo mode on the servo programmer. In our case, we're going to be focusing on regular servos, since continuous rotation servos can be programmed very similarly to the way that we did a motor, just replacing the motor object with a continuous rotation servo.
Now that we have our servo programmed, we can plug it into our control hub just like this. Now that's plugged in, we can go over to our driver hub to set up a config. Alright, now that we have our servo plugged in, we're ready to add it to the configuration. To do that, go over here, hit Configure Robot, find the configuration you're working with, hit Edit, open up your control hub, select Servos, select the kind of servo we have. We have just a normal servo, but if you have another one, select whatever you have. Then name it something. We're going to name it Servo 1, but on an actual robot, you'll want to name something more specific. Hit this done, then hit done, 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 save. And now that your servo's in the configuration, you're ready to write some code. Alright, as you can see here, I have a blank program that I'm going to be using to demonstrate how to code a servo to rotate between two positions. But the first thing we need to do is import a few commands. With this command, import com.qualcomm.robotcore. Then we need this first part a few times, so I'm going to copy this quickly. Then we need to follow it up with .eventloop, .opmode, .autonomous. Then .eventloop, .opmode, .linear opmode, then .hardware, .servo, and for our last one, .util, .elapsed time. And now that we've got that, we can start setting up our code with @autonomous name equals the name of your program. Mine's just going to be called servo. Then under that, public class, the name of your program, it's tutorial program for me, and then we need extends linear op mode, brackets, and space under those brackets. Then we need at override public void, and spelling public correctly would help. Then after that, run op mode. Then go back up to just under this extends linear op mode, and we need to start declaring our servo and our timer. So declaring a servo is just public servo. Timer is elapsed time timer. Then down here under the run op mode, we need to finish declaring our servo and our timer with servo equals hardware map dot servo dot get and our device name, which I'm just going to name mine servo1. You'll want to name it something more specific in your code. Then to finish our elapsed time is just timer equals new elapsed time. Then we also need in this section a wait for start and a timer dot reset, so that when our actual code starts, our timer will be reset for what our code uses it for. Then our actual code will be in a while mode is active. And once we have this ready, we can start actually setting up our servo to move with if timer dot seconds is greater than 2, servo dot set position 1. So with this, as soon as the timer hits 2 seconds, the servo will go to position 1. And the other thing we want right now is if timer dot seconds again. This time timer dot reset. But right now our servo will never go out of position 2 because we haven't told it to do anything else anywhere. Which is why under here we need an else servo dot set position 0. And I forgot to put a timer in here. We want just a greater than 4. So with this, our timer will hit 2 seconds, our servo will go to position 1, hit 4 seconds, reset, be at position 0 until it hits 2 again, and that's all the code we need. Alright, now all we need to do is run our program, and we can see the servo start running, flipping every 2 seconds just like we coded it to.
In this section we're going to be talking about sensors, and we're going to be focusing on the Rev color sensor V3 because it's a very commonly used sensor and it's also very versatile, being able to detect red, green, blue values as well as alpha values, and having a rough distance approximation. So it's a very useful sensor that has lots of different applications in both autonomous programs and in doing automations for your teleop programs.
So, now we'll take a Rev color sensor and an I2C cable, plug the I2C cable into the color sensor and into one of these I2C ports. Now your color sensor's plugged in, you can use this switch to turn this switch on the side right here to turn the light on and off. Now let's open the config to get this set up. Alright, now that we have our color sensor plugged in, we can add it to the configuration. Go up here, hit configure robot, find your configuration, hit edit, open up your control hub. You're going to find I2C, whichever port you plugged it into. It's 3 for us. Click add, select whatever you have. We have a color sensor version 3. Then you're going to enter a device name. If you have more than one sensor, you'll want to name it something specific. Since we're only demonstrating with this one, I'm just going to name it color. Then you can hit done, 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 save, okay, and you're ready to write some code. We can initialize and hit play. You should see your screen start to print values for red. it'll always do that because it'll always be seeing some red because, you know, there's some red everywhere. But if you put it against something black, it'll see a lot less red than it was seeing in the air, and it'll see even more red if you put it against something that is actually red. And that's about it for a color sensor.
Alright guys, that brings us to the end of our video. Thanks for watching. Here we have some other resources listed that you can use if you're having any trouble or want to learn some more about programming with your robot. There's a lot of example code in the FTC repository that you have in your Android Studio. That example code is very well documented and very useful, and it covers a wide variety of applications for your code on your robot, so I would definitely recommend checking that out. There's the First Tech Challenge YouTube channel. They have a playlist called Programming with Java. It goes over a lot of what we went over in this video, but if you need some more examples and some more help with the programming, definitely look at checking that out. There's also the First Tech Challenge On-Bot Java Guide. This PDF is super useful, especially for hardware setup. It covers both legal Android phones and the driver station for setting those up. If you had any trouble with the hardware, definitely look at checking that out. And the On-Bot Java Guide also includes some programming tips for writing in Java. So I would also highly recommend checking out that PDF. Once again, thanks for watching, and good luck this season.